everyone. It is Tanner from SuperNOVA, and today we are talking about biodiesel production and water effects. So let's just jump right into it. Today, we live in a very climate conscious society, and one of the biggest reasons why is due to the increase of greenhouse gases produced from pollution. Scientists want to fix this and develop cleaner energy solutions. Some of these solutions are called biofuels. But what is a biofuel? Well, biofuel is a liquid fuel made from renewable biomass. But more on that shortly. See, biofuels are becoming to look like a viable alternative option to compete against traditional fuels such as gasoline and diesel. But we have a long way to go. At the moment, the biofuel industry is mainly geared towards biodiesel and not biogasoline, which means that in the near future, we will start seeing trucks, buses, and farming equipment making the transition to biofuels, where we will have to wait some time before people start putting it into their personal cars. It is important to note that there are two main types of biofuel, one being bioethanol, and the other one being biodiesel. We're going to talk about biodiesel. Before we get into the impact of the production of biofuels, what exactly are biofuels, and how do they work? Biodiesel, like diesel, can be used in diesel engines. But unlike the standard diesel you can currently get at the gas station, it is made from renewable materials, such as plant oils, cooking waste, other oils, such as from fish, animal fats, and even more. When a renewable organic material comes from plants and animals, it can be called biomass. Here we have a large field of yellow flowers containing black seeds. The seeds can be extracted, so taken from the husk of the seed and turned into oil. In this case, vegetable oil. But the oil taken from the seeds can also become biodiesel. So let's see how that's possible. Biodiesel is made from things like plants or used cooking oil. First, we clean the oil to remove dirt and all the yucky stuff. Then we mix the clean oil with something called alcohol and a special helper called a catalyst that will speed up the rate of the chemical reaction without undergoing any chemical change itself. This mixture has a special reaction, like mixing ingredients to make a cake. After that, we separate the biodiesel from the other things that were made in the reaction. We wash the biodiesel to make it really clean, and there you go. The feedstock goes through a process called transesterification and consists of fatty acid methyl esters, FAME, FAME. Transesterification is a reaction between the oil or animal fat with an alcohol and a catalyst. Imagine you have a really cool toy car that you love to play with. Usually, this toy car needs special fuel to run, just like a real car needs gasoline. But what if I told you that you can make a different kind of fuel for your toy car? And this fuel comes from things like plants and food scraps. That special fuel made from plants and leftovers is called biofuel. Resources to produce biodiesel are truly vast, from crops to waste to algae. So when we talk about biodiesel, we're talking about a kind of fuel that doesn't come from digging up the ground for materials like oil. Instead, we can use things that we are able to grow and produce in a more eco-friendly way to make this special fuel. It's like having a toy car that runs on the power of nature. Imagine the large fields of crops you may have driven by. Well, that all needs water. And when thinking sustainably, we want to use all the water we have as effectively as possible. The uncleaned wastewater created from the biofuel process can be used for farm irrigation, as long as it does not contain methanol. In our first example, our filtration material is sand. Sand is a common material found worldwide, including in deserts, beaches, stream banks, and other landscapes. The average particle size of sand is about 0.05 to 2 millimeters, which is not very large. In filtration, sand can be used to remove suspended particles, or in other words, the waste floating in the water. In this case, we have coffee grinds mixed with water. We see that using water and gravity, we have separated most of the coffee from our water. In practice, the idea is the same. Sand is used to purify water, leaving the dirty particles in the pores of the sand. This process has gone on for ages, with evidence found in Roman times showing sand was used to filter the water for human consumption. Pea gravel can be commonly found on playgrounds and is another material that can be used to treat water. The gravel is used just like sand, but forms larger, permeable layers. Water can pass through, but some of the dirt particles get trapped. The particle size of pea gravel and gravel in general is much larger than sand. Gravel can be mixed with sand to create even better filtration. The larger gravel traps the larger contaminants, and then the sand can trap the smaller dirt particles. We are now using a different type of gravel. This gravel is synthetic, meaning it does not occur naturally and was made by people. This is aquarium gravel. The pore sizes are very large, and the results are contaminated water at the bottom of our filtration system. Unlike in our previous examples, the small specks of black remain in our filtered water. Can you guess why this happened? Well, it happened because the particle size of our filter material was just too large, and most of the contaminants passed through. Biodiesel is a renewable fuel made from various feedstocks such as vegetable oils, animal fats, and recycled cooking oils. It is often cited as a more environmentally friendly alternative to conventional petroleum-based diesel fuel due to its potential to reduce greenhouse gas emissions and reduce dependence on fossil fuels. However, like any energy source, biodiesel production and use also have environmental impacts that need to be considered. Positive environmental aspects to recognize are the reduction of greenhouse gas emissions. So biodiesel has the potential to significantly reduce carbon dioxide emissions compared to conventional diesel. This is because the carbon dioxide released during its combustion is roughly equivalent, so the same, to the carbon dioxide absorbed by the plants during their growth, making it a carbon neutral or carbon reducing fuel. Also, it's a renewable resource. Biodiesel is made from renewable feedstocks like plant oils, animal fats, and algae, which can be replenished through agriculture and natural processes. Finally, let's look at domestic production. Biodiesel can be produced locally, reducing the reliance on important fossil fuels and enhancing energy security for all kinds of different societies. But now let's consider the other impacts biodiesel production may create. Let's look at land use. The cultivation of feedstocks for biodiesel, such as palm oil, soybeans, and corn, can lead to deforestation, habitat loss, and competition with food crops for land. This can result in a negative environmental impact, including loss of biodiversity and a disruption of the ecosystem. Also, there are the agricultural inputs. Basically, the production of feedstocks require agricultural inputs such as fertilizers and pesticides, which can lead to water pollution, soil degradation, and other environmental issues if not managed properly. And finally, there's resource intensity. Basically, biodiesel production requires significant resources, including water, energy, and land. The extent of these impacts depend on the feedstock used and the production methods employed. Producers of biodiesel need to keep all of this in mind. But with proper management, these issues can be averted. Remember how we discussed using excess wastewater for irrigation? Well, this could cause a process called leaching. In agriculture, Leaching refers to the loss of water-soluble plant nutrients from the soil due to rain and irrigation. Soil structure, crop planting, type and application rates of fertilizer, and other factors are taken into account to avoid excessive nutrient loss. Leaching is an environmental concern when it contributes to groundwater contamination. As water from rain, flooding, and other sources seeps into the ground, it can dissolve chemicals and carry them into the underground water supply. Of particular concern are hazardous waste dumps and landfills, and in agriculture, excessive fertilizer and improperly stored animal manure. So you want to make sure you're properly storing certain biomass. Now, in a similar way, when we want to make biofuel from certain plants or materials, we need to get something valuable out of them. But the valuable part isn't just sitting on the surface. It's stuck inside the plant material. So, we use a special liquid, a bit like water, to help us. We pour this liquid over the plant, and as it goes through them, it takes out the important parts we need for making biofuel. This process is also called leaching. It's like the plant gives away its special parts to the liquid. After we're done, we can use the liquid with the valuable parts to make biofuel. So, leaching is a way to get the important stuff out of the plants so we can use it to make something helpful, just like biodiesel. The production of biodiesel carries several social implications that span across various dimensions. On one hand, biodiesel production can contribute positively to rural development by creating employment opportunities, particularly in agriculture and manufacturing sectors. This can help alleviate poverty, enhance livelihoods, and strengthen local economies. Furthermore, the cultivation of feedstocks for biodiesel can provide an additional income source for smallholder farms and thereby promoting inclusive growth. However, the social impact of biodiesel production isn't uniformly positive. If not managed carefully, the competition between biodiesel feedstock crops and food crops can lead to increased food prices and potential food scarcity, disproportionately affecting vulnerable populations. Land use changes associated with large-scale biodiesel production may also lead to displacement of indigenous communities and disruption of traditional land use patterns. Therefore, a comprehensive assessment of the social implications coupled with appropriate policies and community engagement is crucial to ensure that biodiesel production contributes positively to social well-being and equitable development. Biodiesel can be used with some precaution in diesel engines in many sectors, including on-road vehicles, off-road mobile equipment and vehicles, and stationary equipment. For on-road, there could be fleet vehicles, heavy-duty trucks, school buses, urban transit buses. And off-road, we could include agricultural equipment, construction equipment, forestry equipment, locomotives. Yeah, that's right, trains. Marine vessels and mining equipment. Have you ever seen a train powered by biofuel before? Well, in the future, it may not be as uncommon as you think it will be. They could be coming to your city soon. Currently, the United States and Brazil remain the highest producers of biofuel in the world. But we can see Canada and many other countries are following suit, as there are emerging opportunities for those interested in biodiesel production. Biodiesel can be produced locally in Canada and can also provide local economies with a new market for their agricultural products and waste, reducing the industry's disposal costs. Agro-industry residues such as slaughterhouse waste, restaurant cooking oil, non-food grade virgin oil, or agricultural surplus, once destined for a landfill, is a commodity in the biodiesel business. On a national level, biodiesel incorporated in the energy mix will encourage new business opportunities, greater investment, employment, and provide a new energy alternative. I want to thank everyone for listening along, and I hope you stay tuned to see what else the Atlantic Clean Energy Stewards Program has to offer at SuperNOVA.